Goes over to the other side, however you'd like to do it. So 13.5, so that becomes 27.9. So it's 1860. Okay.
So could you, because we know R1, can you now figure R2?
Yeah.
Just out of there?
Yeah.
Okay.
Same thing, right? We don't have to worry about what's going on with the geometry of it, right? All our equilibrium, as long as we meet all of our equilibrium conditions, it does not matter to us how we set up our beam,
Okay.
okay? As long as we're in equilibrium. So R2 is going to be...
What would their sense be though?
640. I'm sorry?
So R2 being 640 would be pulling in which direction?
It's still going to be positive, right?
Okay.
This is also going to be positive.
Okay.
Okay?
Alright.
Does it make sense to us why R1 has the need for a larger capacity?
Yeah. It's surrounded by all the waves.
It's picking up a lot more of the weight, right? Okay? What would this look like if we took our moment about R1?
Negative
Five.
500.
500 times 4?
Yep. And Marshall said that it's negative. Does everybody see why it would be negative in this case?
Because it's going that way.
It's trying to push this way, right? Do we need to take R1 into account? It's passing through the point that we're looking at, right? It's not causing any rotation. What about 1,200 pounds?
Yeah, and that would be just at 3
3.
feet. Yeah, 3 feet.
Is it negative or positive?
Positive.
It's positive this time, right?
Mm-hmm.
Because now we've come to the other side, and now it's trying to curl this way around. Okay?
And then
800
800 at, what is it?
10?
10? No.
Yep.
Yeah.
Yep, 800 pounds times 10 feet.
And R2 divided by, or R2 times 10, 15, 19.
And how is R2 acting? Is it trying to rotate it this way, or is it trying to rotate it this
It
way?
would be negative
It's a negative
because
value, right?
it's going up.
Okay. So now we just have that 8,000 and 3,600, so 11,600 minus the 2,000, 9,600. My public school math is correct. 3,600, 8,000.
Oh, where the hell you went to public school?
Minus 2,000, 9,600, right? So 9,600 divided by 19. So that'd end up
I
being-
got 505.
Yeah. Let's check your math.
Something's wrong.
Check your math.
Is it times 19 or is it times 12?
Yeah, because went to 5, R1
Yes.
stops at,
This should be 15,
Yeah.
right? Yep. Thank you.
640.
Now it gets to 6, okay? So we're good.
For
But
that.
Justin, I would agree with your assessment. I would also do R2. That just, when I look at that, that looks,
Makes it
it
easier.
looks
So-
easier, right?
But when they're both, well, let's finish this.
Yep,
So to do now the shear,
okay?
these are the ones that dip on, or was that even shear? Or was that bending?
So that means,
That was bending.
would you start at 500 down then? If you're going to try to go
Yeah,
over
right.
the-
So you have to decide
Which side you're starting?
which side are you gonna start from. Now,
Can we start from?
up until this point, we've been moving left to right. Is that what you would like to continue doing?
Yeah.
Okay? Okay, so moving left to right,
You'd start below the exit. You'd start below, at five.
yeah,
negative
yeah, we
500,
have
right?
negative 500, right?
Yeah.
Because because R1's not at the end.
It's just the orientation choice that
Yeah.
we've decided to make for this scenario.
Okay.
So we would start at minus 500. Okay? What's our shear here?
500 times,
1,860.
Do we have any other forces acting between here and here?
No.
So do we have any additional shear? It's gonna stay at 500, right?
oh yeah,
Until the time that we get just past R1.
Just past R1 is where the 1860 is.
That's where our 1860 is gonna pick up. Okay?
Okay.
Remember to keep the distinction. In shear, okay, when we have our point loads,
So are you saying the 1860 is technically not at 4 feet? It's just past, like, it'd be like 4.1 or 0.000.
it'd be like
feet?
4.000000001.
Yeah.
It's an infinitesimally small. I mean, if we really wanted to determine it, we'd have to do calculus. And
Right.
we're just gonna bypass the calculus and assume that that's how it's working.
so at R1 it
Okay.
shoots up to 1360.
So, yep, so 4 feet away. Scale here. So a little more distance. So we're gonna be at 500 until we get here, then we're gonna jump up to 1360. Okay, then what happens?
We jump down to
Hold on.
160.
160.
We're gonna stay at 1360, right?
Oh yeah, for 3
Until,
feet.
for 3 feet,
Yeah.
then we're gonna drop down to negative 160.
No, to 160.
What? Oh, yes, sorry. Yeah, we're only dropping down 100, right?
3 feet, bro.
Okay? Now what do we do?
Go
Staying at
7
that
feet,
plane.
Staying at 160,
Go 7 feet,
then drop down to
640.
negative.
Yeah, 640.
yep.
And then back up to 0.
No, you'd end at
At
640.
R2. I mean, I'm saying back at R2.
We run at 640 up until R2. And then we're gonna pick up our
Like that?
reaction,
That's what I said.
right?
Oh, I thought you meant at an angle. I was like,
No.
What the fuck are you talking about? It's negative
I didn't say
640.
anything about it.
Okay, so
Run it
where
back.
does our max shear occur?
R1.
It's still occurring at our greatest reaction,
Yeah.
okay?
So it crosses, would you say it crosses 0 at
At multiple
10
points.
feet?
Would you
Or
say?
where, yeah, where do you say?
You'd
it
say
crosses?
at 4 feet and at, where is that, 14 feet?
So it crosses at 4 feet and it crosses at 14 feet.
14. So you're counting from the beginning, okay. I was
Remember about bending at our supports though. Do we have bending stress at our supports?
No,
Why don't we have bending stress at our supports?
because that's where the support is. right?
That's where we're,
Yeah.
yeah, that's where we're clamped into them, right? We don't allow them to bend at those points.
So
They
technically.
can
it'd
bend,
be at
they
10.
can bend on this side
So it would only be at 10 feet.
and they
Or-
can bend here.
So yeah,
No,
so,
it'd be, we don't count from R1 over, right? We count the whole, so it'd be 14 feet is the 0 that you count.
Yeah, 14 feet from the left end of the beam. Yep, or 5 feet from R2.
but technically you wouldn't count R1
Yeah,
bending moment as,
Right.
that wouldn't be a
Right.
bend because that's
yep,
where.
because what we'll find is we're not going to have a bending moment.
Right, because that's where we're supported.
Yep, yep, our beam is being supported then.
Okay.
Okay?
If you do the shear diagram starting from R2,
No, we did it from.
can you still start on the left-hand side?
We
But
did
just
that.
start at 640?
We started at R2.
We started at.
Say it again. Sorry.
Oh, we did R1.
Oh, the shear
We
diagram.
move,
Oh, you
Okay.
so
said
the
starting
shear
at
diagram, we
R2.
move left to right.
Okay, no matter where you start R1 or R2.
I don't understand.
Yeah, because we started at negative 500 because that's.
Are you talking about the equilibrium analysis?
No, the shear diagram.
That,
The shear diagram, we started at the left-hand side of the beam
Because we did R1,
and moved across.
but if you did R2.
No, we did R1 and R2.
Could do it either way.
You can do it either way.
It's gonna
I think
look the
R1
same.
R1 always has to stay on the left side, right? Is that what you're trying to do?
are you trying to put R2 first and R1
Yeah.
over here and just draw
I'm trying to do the
640?
shear diagram starting from R2.
Oh,
Why?
sure.
I'm just asking if
All
you
it's going to do,
would you still start R2 on the left-hand side?
no, because if you're starting from the left hand, if you're starting from R2, you have to start and go right to left, right?
Yeah.
Our magnitudes won't change, but our sense will. Okay, so it's going to instead look like,
Yeah.
Oh, okay.
okay? And again, does the beam care if you apply your loads like this, or if you apply your loads like this?
No, as long as you're.
Provided the magnitudes are the same, right? That's all the beam cares about, is the
Well.
magnitude.
Because that just confused me.
You stick with R1.
Yeah, I'm gonna, I see it's like a mirrored image, but,
It's like the
Yep.
inverse.
it's not big.
And that's all we're, but that's all we're doing though, right?
Video later. What the?
We just, instead of starting from here and going to here, we started from here and went to here.
Isn't it
I
the
get
same?
it.
We're
It's
we're
just,
just,
inverse,
we're
right?
just mirroring it, is all that we're doing,
Same number.
okay?
So it's all negative.
Right, this kind of question.
Okay, so our V equals 0 that we're interested in is at x equals 15 feet.
Mm-hmm.
Okay? So now let's look at what's going on with our bending moment.
You know what's crazy? This is the same problem still.
Yep. You know what's crazy is that if this was a 90-foot bridge, we'd have 4 other sections to analyze.
Not an engineer.
Okay, so
All right.
x equals 0.
No.
Bending? We don't have any bending, right?
Wait.
Yeah, we do.
Yeah, we do.
Oh, no,
this
no,
going through the
no.
point.
At
Okay,
one
I
we
got
would.
Right. At 1 we do.
You're so tricky.
Okay.
I tried doing it in the same order.
I know,
I know,
but see, this
but
is where
still.
like where you got to move from doing this kind of stuff to where it,
Let's look at x equal 2 actually, sorry.
Thank you.
What are we picking up at 2 foot?
so you're gonna do 500 times 2,
Negative.
negative 500 times 2
And then,
times 1.
yeah.
You want to do what?
Right?
Then
Did you get a cut the distance in half?
Is it uniformly distributed?
I don't know.
No. You keep it as it is.
We only do that for our uniformly distributed loads, right?
Oh.
And then we gotta account for R1 too.
Do we have to account for R1 here?
No, never mind, because we're only looking to the left.
Got it.
Yeah.
Okay. Let's see.
So,
So at x equals 4. What do we have?
so you have that 500 times 4. Net, we're negative 500.
Wouldn't it still be the same because R1 technically wouldn't be?
Well, this is where you would use R1 now, isn't it?
Well, no, because it's going passing through.
No, because remember, we're doing bending.
Oh, because it's going right.
We're doing bending here.
So it's the same. Right. Oh, it's just.
It's not gonna be same,
Not the same.
right?
but-
Because we're increasing that
Yeah,
distance.
but
Talking
R1's
about
still
bending.
not.
Yep.
Yeah.
Point loads stay constant in shear,
Yeah.
but
So
they
bending
increase in
goes
bending,
and
Yeah.
okay?
Okay.
What about x equals 7?
Negative 500 pounds times 7, plus,
What's that, 7 feet? Okay.
what's R2 again? Or R1?
R1's
1860.
60.
Plus 1860
times 3,
times
right?
3.
Okay?
Oh, is that, that's negative though, because it's to the left, because we're talking about at 7 feet, right?
It's pushing,
Wait,
it's pushing.
Oh, no, it is.
Keep in mind,
But
we're
it's
talking about
R1.
moments, right? So we're talking about how it's trying to rotate.
Okay, yeah, so it's going, yep, never mind.
but
So-
at 7 feet, you're out here, and R1's over here.
Yeah, so it's still, it's pushing up, so which would
Oh,
make it positive.
okay, yeah, all right. I got you. Yep,
Think about it rotating.
yeah.
So
What's my
3,500
brain, man?
I don't know.
plus 5580,
Okay, so what is that?
so 2080 pound-feet. $208. Okay?
You look at,
How about at x equal 15?
okay. So, negative 500 times 15
Mhm.
plus 1860 would be, okay.
Yep.
So then that still wouldn't
Plus-
count, that wouldn't count the 800 though.
Is that not,
Oh,
yeah,
no.
because 800's at 14.
We still wouldn't count,
Oh, yeah, you would.
yes, we would, yes, because
Yeah.
we're now,
You just crossed it a foot.
Okay, yep.
We're at that point.
So
then
now
800
it'd be
times
plus 800 times 1.
negative 800. Negative 800?
Negative
Yeah.
800, yeah.
anything else?
The what?
The negative 1200.
Oh,
How
shit.
far away is that?
8 feet.
Yep. Okay.
Yeah. Okay. So, but the R1's positive in that whole deal.
The R1 will be positive, yep, because we're grabbing on here,
Okay.
right? So R1 is trying to rotate this direction. Everything else is gonna be negative.
Big moment.
Is that 1860 times 11 feet?
1860 times
Yeah.
11, yep. Plus 18,060, 18,600, sorry. So 6, 4, 9.
You got 2560. What'd you get?
So 16 and
Is that what you got?
17.4, 17.9. What'd you say?
2560.
25.60.
Yeah.
So I dropped a 1 there somewhere. Okay. Happy so far, right? 25.60. Still got our maximum. Okay. Let's just look at. Let's take a peek at.
That is our maximum. Isn't it?
Let's take a peek at x equals 17.
So, negative 500 times. 14 plus 1860 times.
feet, right?
Wait, what would it, yeah, 13.
Ten feet.
Makes a lot of sense.
What was it, 800 times 3?
800 times 3, right?
Well, maybe.
$12.80.
Yeah. Well, at least that's what I got. So that would be the start and the terminator.
Yep. So we're going to, so we're gonna bring this guy back up a little bit here to draw this thing.
So,
Okay, so starting at 0, dropping down,
so we go to
okay? And remember that this inflection point is being caused by our reaction, okay? Right?
So, for the answers, you know, we're always saying, okay, the greatest, the point of the greatest bend on this one,
Where your maximum bending moment is, yep.
25.6 at 15.
Yep.
But that may not be really it. I mean, what if it was like 14.5? I mean, is it just 15 because we just chose to do 15? I mean, what if it?
No, it's
Okay.
15 because that's right. Oh, you mean if
We
you want
just
to plug
chose
this in?
15, you know what I mean? Like,
Yeah, I mean, we could sit here and calculate this all day.
Okay,
I mean,
so-
what we would actually do is throw it into a software package and run it through finite
So
element.
if we choose 2 or 3 or 4 things to solve, and I got, here's my biggest, now I'm going down to my next one, that's my max bend, is because that's what I figured out it
Yep.
would be.
Yep. So
Doesn't
if
mean
you
that
have,
is the absolute max bend.
say that again?
That doesn't mean that is, for that whole curve, the truest max bend.
Yeah, right here.
That's not 15 feet though.
What are you talking about? Oh,
It's 14 feet.
sorry, my scale is. Should be like that.
I'm just saying that's 14 feet.
The
Fif-
negative 650, 40.
Yeah, if you say the max bend happens at where that negative 640 is,
Yep.
that's 14 feet. We figured it on ours. I'm just saying that MX 15, we got 2560 out of right here.
Right.
That doesn't
right,
mean
right.
that's the biggest
Right,
bend out there.
I wrote down here, I wrote that down wrong. Yes, we should have analyzed that at 14 feet.
So you get what I'm
Yes.
saying?
Yeah,
Just
yeah.
because I picked 15 doesn't mean that's the.
No, I see what you're saying. We analyzed at the wrong point. You should
But if
run
I
it
got
at X
that and I was
equals
like, hey, that's
14.
that's the biggest one, I'm gonna put that as my max. Am I wrong?
M of X equals 14,
Do you know what I'm saying though?
is gonna equal minus 500 times 14 plus 1860 times 10 minus 1200 times 7 minus, it won't have anything to do with the 800, right? So we have
And that's why it's
minus
bigger,
7,000.
because we're not taking the 800 in there.
Yep, minus 8,400. So that's minus 15,400. And that's 1860.
Yep.
So our difference there is
300.
3,200.
Yeah. But you see what I was getting at?
Yep, I just wrote that down wrong and then we analyzed it at the wrong point. No, by definition, your maximum bending moment is always going to occur where your shear
Where
equals
the-
0.
That's what I thought, that's what I was
That's
like, well, wait a minute.
always, yeah. I just wrote that point down wrong and then we looked at the wrong point.
Okay.